Hello students, how are you? My name is Dr. Jyoti Singh and today I am going to discuss with you about milk cream. In this video, we are going to discuss about cream, how it is made and what are the various types of creams, and also we will be discussing some of the physico-chemical properties and nutritive value of different creams. So let's start. First of all, let us know what is a cream. So a cream is an emulsion of oil in water, and butter is an emulsion of water in oil. Milk cream, also known as simply as cream, is a rich and fatty components of milk. It is the layer of fat that naturally rises to the top of milk due to its lower density. So this fatty layer can be skimmed off and it serves as a wide range of culinary, industrial and dietary purpose. As we can see here, if this is a milk, then the lower level is called skim milk, while the upper layer, which turns out to be rich in fat, is known as a cream or a layer of cream. Now let's move ahead. Let us know about the composition of milk cream. So milk cream is the main component of the milk cream is fat. So the defining characteristic of cream is its high fat concentration. So the fat content in cream varies depending on the type of cream. It typically ranges from about 18 to 40%. The higher the fat content, the richer and creamier the cream will be. Now the next content is water content. Cream is not just only fat. It also contains water and it contributes to the smoothness and creamy texture of the cream. The next component is protein. While cream is primarily made up of fat, but in little amount it contains protein as well. So even though it is only present in small traces amount, but it is there. Other nutrients like cream is a source of various essential fat-soluble vitamins like vitamin A, D, E and K, and minerals like calcium as well. Now the composition of milk, the whole composition of milk, we can see the milk is majorly constituted of water, then we have lactose as sugar, then fat and then protein and then minerals. Now types of cream. According to Food Safety and Standard Authority of India FSSAI 2011 norm, cream including sterilized cream means the product of cow or buffalo milk or a combination thereof. It shall be free from starch and other ingredients foreign to milk. It may be of the following three categories, namely low fat cream. Its fat content should not be less than 25% by weight. Then medium fat cream, its fat content should not be less than 40% by weight. Then high fat cream, cream containing not less than 60% fat by weight. And if there is not mentioning of the percentage of fat in the cream, then the cream would be considered as high fat cream. Now we can see what are the constituents of low fat cream and a medium fat cream. So there is a difference, there is majorly the difference of fat and the water percentage. As we can see from here, in low fat cream water percentage is 68.2%, while in medium fat cream it is around 45.45%. Talking about the fat composition, like fat is 25% and here fat is 50%. Rest of the constituent like protein, lactose as total solid and solid non-fat, almost it is similar kind of thing, but the major difference lies in the content of water and fat. Now the fat based standards for various types of cream vary in individual countries, and diverse names are used to describe different creams. Universally accepted classification, however, table 1 provide us the regulations for the fat content of cream product in major cream producing countries. Like cream products are also can be classified according to their final uses. For example, whipping cream, coffee cream, cream liqueur or processing methods used for their preparation like pasteurized cream, ultra high temperature treated creams, frozen cream, dried creams, cultured or sour cream. So here are few nomenclature based upon the uses, and the cream standard is not universally accepted, so that's why different countries have different norms for the percentage and type of cream as per their uses. For example, in France, light cream is having 12 to 30% of the fat. In Germany, coffee cream is having 10 to 30% of fat, while in Netherlands, cream means 10 to 30% fat cream, and in United Kingdoms we have half cream, single cream, whipping cream, double cream. In United States we have half cream and half cream, light cream, whipping cream. So it depends upon their culture and society from which name they are calling a certain type of cream. Now, few common terms which we usually encounter in our daily life, that is cream. So if a product is been labeled as cream, then it must be having some 18 to 26% of cream. Now we have light cream or coffee cream. It contains fat less than 10%, and heavy cream, its fat content is more than 35%. Then whipping cream is having fat content around which is more than 28%, and we have double cream which is having fat content more than 45%. So these are some of the commonest terms which we encounter in our daily lives. In addition, vitamin, enzymes, trace elements and acids are also present in cream. So it can be observed from the above composition that the higher the percentage in cream, lower the solid non-fat content. So the formula for determining the percentage of non-solid fat in cream is percentage SNF in cream is equal to 100 minus percent of fat in cream divided by 100 minus percent of fat in milk multiplied by percent SNF in the milk. So this is the formula which we use for calculating the percentage of solid non-fat in the cream. Now, production of milk cream. So cream is separated from milk using various methods such as centrifugation, gravity separation and ultrafiltration. So let us discuss one by one all these methods. First of all, I would like to discuss about the principle which we use for the separation of milk from the cream. So the basic principle for cream separation, whether by gravity or centrifugal method, is based on the fact that milk is lighter than the skim milk portion, and at 16 degrees Celsius the density of milk fat is 0.93 and that of skim milk is 1.036. So when milk is subjected to gravity or centrifugal forces, the two components with cream and the skim milk, by virtue of their differing densities, stratify or separate from one another. So this is due to the separation of cream from the milk is done on the principle of gravity differences or the density differences between the two. Now let us discuss about gravity separation method of milk. So gravity separation method involves sedimentation by gravity, was also the original technique used in dairying to separate fat from milk. Milk fresh from the cow was left in a vessel, and after some time the fat globules aggregated and floated to the surface, where they formed a layer of cream on top of the milk that was then skimmed off by hand. So it is common method of fat separation which is governed by this principle and adopted at household level. Now the rate at which the fat separates is governed by the Stokes law as given by the following equation, which is having like rate at which the fat globules rises is equal to 2 into acceleration due to gravity in brackets density of skim milk minus density of fat into radius square of the radius of the fat globule divided by 9 viscosity of the skim milk. So this is the Stokes law which determines the movement of any particle into a fluid solution. So we are here calculating the rate of cream formation or fat globules coagulation into skim milk, which is calculated by this formula which is known as Stokes' law. Now, so the gravity method of separation is a slow and simple process. It is followed at household and cottage level. It separates fat from milk in the form of cream. So this is the easiest way to separate cream. Fresh or boiled and cooled milk is left to stand in a vessel, and after a while the fat globules cluster or aggregate to rise to the surface, forming a layer of fat-rich cream. So the layer can be removed by handle or ladle. If the milk is not properly heated, it may undergo undesirable fermentation, sometimes leading to curdling of milk. So the separation of fat will occur, but the resulting cream and the skim milk will be very poor quality. The fat separating on the surface of milk in the form of skin is scooped, and the process is repeated at least 2 times to extract fat. So by this method, it is possible to extract about 50% of the fat which is present in the milk. Now the fat thus obtained is preserved with lactic acid culture to avoid putrefaction. So the rate of separation of fat by gravity method is affected by following 2 factors. First, the size of the fat globules. If the size of the fat globules is bigger, the separation will be faster. So this is the reason separation is faster in buffalo milk as compared to cow milk. The second factor is the temperature. It affects the viscosity, which in turn influences the flow of velocity with which the fat will be separated. Hence, the separation at higher temperature is faster because of the reduced viscosity of the milk. The third factor is clumping of the fat globules together increases the size and thus increases the velocity and rate of separation. Now the second method for cream production is centrifugation. So a centrifuge is used to separate the heavier cream from the lighter milk components based on their differences in densities. So the centrifugal force acting on the system is about 3000 to 6000 times greater than the gravitational force. Hence the separation of fat, which is governed by the Stokes' law, is faster than the gravity method of separation. Fat globules of smaller size separate 6500 times faster in a centrifuge rotating at 5400 rpm than they do by gravity method of separation. Here in the diagram we can see, like the milk is having so many of components, and since the fat is lesser in density, less denser than the skim milk, it turns out to be present at the top after centrifugation, and skim milk is present in the bottom side. Now, how does a centrifugal milk separator work? So, it speeds up the milk separation by using centrifugal force. A centrifugal milk separator machine has conical discs that rotate in a bowl or drum at a speed of around 6000 to 10,000 rpm depending on the model of the milk separator. Now this is the figure which shows the disc which are being used into the milk separator, which separates the cream from the skim milk. So when the whole milk gets inside the bowl, the centrifugal force runs it through the holes of the disc. So the milk fat globules go to the center of the drum and the skim milk goes to its outer edge because it is heavier. That is how cream extraction happens. Now generally the milk is preheated at 37 to 50 degrees before separation for optimum results. This makes the process easier and more efficient as the warm milk is less viscous than the cold milk. Milk is fed down as an inlet tube into the separator bowl where it rotates and moves up through a series of aligned holes in the disc rack. Then inflow of milk is regulated by adjusting the milk inlet valve to the separator. As the disc stack revolves, the cream moves towards the center of the bowl and the skim milk is directed outwards by the centrifugal force. So thus milk is separated in two streams, a highly concentrated milk fat stream termed as cream and a non-fat stream of skim milk. Under normal conditions, it produces skim milk and cream in the ratio of 90:10. Now, production of milking, it is a schematic diagram showing how the milk is being separated into cream and the skim milk. Now, physicochemical properties of cream. So, first property is viscosity. The viscosity indicates the richness of the cream. It is affected by the factors like fat content, temperature, separation conditions, homogenization, cooling, storage and clumping of the fat globules in the cream. So here is a diagram which shows how native milk fat globule after low heat treatment and after high heat treatment. So during low heat treatment, individual fat globules in the cream remain separate. When we heat this cream to a high temperature, the individual fat globules are being absorbed by proteins which are present into the cream, and due to this protein absorption, the individual fat globules coagulate and they aggregate to form fat globules or larger fat globules into the cream. So heating plays an important role in the physicochemical properties of cream. Now the next property is whipping quality. So it refers to the ability of cream to produce a stable foam or froth when it is beaten with air. The whipping ability of cream is influenced by the fat content, separation conditions, aging, acidity, homogenization pressure, addition of stabilizers and so many other things. So here is a diagram which shows how the whipping quality of the cream is being affected by the presence of water as well as the hydrophilic tails and hydrophobic tails of the fat globule, as well as with the presence of water molecules, and due to this whipping cream get its foamy nature. Now specific gravity, the specific gravity of cream decreases with increase in the fat content. Then tritable acidity, the tritable acidity of fresh cream is inversely related to the fat content. It can be calculated by the formula given below, that is percent tritable acidity is equal to percent serum in cream, percent serum in milk multiplied by percent tritable acidity of milk. Now nutritive value of cream. So fresh cream contains all the nutrients of milk but with invariably contain at least 5 times more fat than the milk. Hence the energy value of cream will be several times higher than that of the milk. The energy value can be calculated by assessing the composition of milk and taking into consideration the individual contribution of the constituents to the energy value as given below. Milk fat yields 9.3 kilocalorie per gram, milk sugar gives you 4.1 kilocalorie per gram, and milk protein gives you 4.1 kilocalorie per gram. So in addition to the calorific value, the cream is richer in fat soluble vitamins like vitamin A, D, E and K than milk, as it has more fat content. Then fat losses in skim milk. So there are several factors which influence the efficiency of cream separation process. Consequently, the entire fat present in milk is not recovered during centrifugal separation. The percent of total fat recovered in cream from milk is referred to as skimming efficiency. The skimming efficiency is calculated by the equation given below, that is the skimming efficiency is equal to total fat in the cream divided by total fat in the milk into 100. Factors affecting the skimming efficiency are temperature of milk. The temperature of milk at the time of separation should be around 37 to 50 degrees Celsius. Separation at lower temperatures results in higher fat loss in skim milk and may yield to partial clogging of the bowl due to increased viscosity of the cream. Speed of the bowl, the fat losses in skim milk will be higher at lower speed of the bowl. This loss is ascribed to the inefficient centrifugal force generation. Hence, Milk should not be fed into the cream separators unless the cream separator attains its full speed. Now, rate of milk inflow. The rate of milk to the cream separator should be at optimum level. If the flow is at higher rate, it will result in greater loss of fat in skim milk. The size of the fat globules. Smaller the size of the fat globules in milk, higher will be fat content in skim milk. So due to this reason, it is observed that generally cow milk and goat milk have lower separation efficiency in comparison to buffalo milk. Presence of air. Greater the amount of air in milk, higher will be the fat loss in the skim milk. The entrapped air reduces the efficiency of hermetically sealed separators more than that of the normal cream separators. Acidity of milk. Higher the acidity of milk reduces the efficiency of separators. This is mainly due to the partial coagulation of milk, which in turn increases the sludge formation in the bowl, affecting the efficiency of separation. Then mechanical condition of separation. Vibration in the machine, use of deformed or dirty or scratched or rough disc, and accumulation of separator slime increases loss of fat in skim milk. Next is fat percent in cream. Production of cream containing more than 50 to 60% fat causes more losses of fat in skim milk. Degree of agitation and temperature of milk. Higher temperature of milk and more agitation causes higher losses of fat in skim milk. Position of cream screw. As high fat in cream causes more losses of cream screw, should be appropriately adjusted. Now, processing of cream. The processing of cream depends on the purpose for which it is required. In general, following processes are involved for different type of creams. That is standardization. The fat content of cream is adjusted to the desired level either by addition of calculated quantity of water or skim milk. This step is referred to as standardization. The use of water or skim milk depends on the purpose for which the cream is required. If the buttermilk is to be used for drying or standardization of milk for products making or for beverages preparation, the standardization is done with skim milk. The purpose for which cream is to be used and the suggestions for use of skim milk or water are indicated below in table 1.5. That is, cream for butter preparation, we can use water for standardization, while for whipping cream, table cream and coffee cream, we use skim milk for the standardization purpose. Now, second processing method for cream is homogenization. Homogenization, in this process, cream is an oil in water emulsion. Therefore, cream standardized to various fat levels with skim milk must be homogenized to reduce the fat globule size and increase the stability, that is, prevent fat separation. So, homogenization is a process whereby cream is forced through a narrow orifice under considerable pressure. So, this breaks up the fat globules to smaller size and ensures they are evenly distributed throughout the cream. By homogenization, various grades of viscosity in cream products can be obtained. Usually, lower pressures are used for cream than that used for cream products. Whipping cream is rarely homogenized, and this process greatly reduces the whipping cream ability of cream. Stabilizers such as monoglycerides are added to improve whipping ability. On the other hand, homogenization of high-fat cream is utilized in the production of spoonable whipped cream products which are used as dessert toppings. Homogenization is employed for UHT pasteurized whipping cream in order to prevent fat separation, which increases the UHT pasteurization. Now, thermal processing. The thermal processing of cream involves either pasteurization or sterilization. The cream could be pasteurized by either batch or continuous method. The sterilization could also be done by either of the two methods, that is by batch method using counter pressure autoclaves referred to as retorts, or by continuous method followed by aseptic packaging. So the time temperature combination for cream is higher in comparison to milk processing. This is simply because it contains more total solids than milk. The possible time temperature combinations are indicated below, that is batch pasteurization. It needs 74 degrees Celsius for 30 minutes. Continuous pasteurization, it needs 85 degrees Celsius for 25 seconds, while batch sterilization needs 115 to 120 degrees Celsius for 15 minutes, while UHT processing just needs 135 degrees Celsius for 1 to 3 seconds. So as soon as the heat processing of cream is completed, it is cooled to less than 10 degrees Celsius to avoid the growth of heat resistant microorganisms during storage. In practice, it is cooled at 4 to 5 degrees Celsius. Now packaging and storage. The cream after processing is packaged in suitable containers and stored at temperature below 5 degrees. If the cream is sterilized or UHT cream, it can be stored at ambient temperature. So that's all for this video. Thank you so much.